Hello everyone and welcome to my video on factoring quadratics a greater than 1 example 1. I'll be doing two of these in two different videos. I would definitely watch this one first and then check out the next one. Alright, so here you can see I have an example for us. So we're going to go ahead and try to work this example out. Now, if you don't know how to factor a quadratic, you definitely want to start with the other videos, GCFs, a equals to 1, because I'm going to be kind of going over those concepts more quickly since we've already had videos on that. So I'm going to show you here how there are definitely similarities and differences between factoring a equals 1 and a greater than 1. The first thing being what that even means, which is a is that first coefficient, the leading coefficient. When it's just an x squared, it's when a is 1, and anything other than an x squared, like a 2x squared in this case, is when a is greater than 1, right? So that changes up how we do things. The first similarity is we're still going to be looking for two numbers that multiply to one number and add to a different one. Another similarity is we're still going to be adding to this middle term. So we're going to want to add to a plus 17 here. Now the first difference is we're no longer multiplying to that last term, 21. We have to multiply the first and last two terms together to get a new number. And we want to be aware of the signs here. So it's going to be a plus 42. And that's going to be what we multiply to. Right, so I need to multiply not to that last term anymore, but to the product of the first and last two. So we're going to multiply to 42 and add to 17. Now the process for finding these two numbers is not going to change. We're going to want to make a table. So when I make this table, I'm multiplying to a positive number, so both signs are going to be the same, and adding to a positive 17 means they're both going to be positive. I'm going to start with 1 and just work through the factors of 42. So we have 1 and 42, which adds to 43, which isn't 17, so that's not what I'm looking for. 2 multiplies by 40, or 242, which is 21. So they add to 23, which is not 17. 4 plus 2 and 42 is 6. 6 divides by 3, so does 42. 3 and 14, they add to 17, and whoop, looks like we found what we're looking for. Again, these are both positive, so plus 3 plus 14. Now, this part's going to be a little different. I'm no longer just going to create two binomials and have, x plus 3, x plus 14. Right, what I have to do now is I'm going to separate the middle term here. So I'm going to separate this middle term of plus 17x, and I'm going to turn it into a plus 3x plus 14x. And so I'm going to take that middle term and turn it into the two numbers I just found. Now, what's not going to change is the first term's not going to change, but now this middle term is going to split into those two numbers, plus 3x plus 14x, and then the plus 21 doesn't change. Now, it does not matter what order you put the 3 and 14. You could do the 14x plus 3x. You'll end up with the same answer, though the work would look a little different. So if you're going to do that and compare it to what I'm doing, it is going to look different in terms of work, but your final answer should be the same. Okay, now, once we do this, we're going to want to do what's called factor by grouping. And so what I'm going to do is I'm going to put the first two sets of terms into a set of parentheses and the last two set of terms into a separate set of parentheses. Now these parentheses are more of a visual thing. Technically, by putting them in like this, they actually make it look like it's a multiplication problem. That's not the case. I'm just putting in these parentheses to kind of separate the two different groups of terms. All right, so what we're going to do now is we're going to find the GCF in each individual set of parentheses. And so I'm going to look at the first two terms, 2x squared and 3x, and I'm going to find the GCF for that. So I'm going to also maybe just make these all one color and make this a different color so we kind of see what's happening here. All right, so here the GCF in the first group, 2x squared plus 3x. Now 2 and 3 don't have a common factor, but they both have an x. And I'm going to go ahead and take that out as a GCF to the smallest exponent that shows up, which would be right here, x to the power of 1. So I'm going to factor out an x, and that leaves me with 2x plus 3. Okay, now I'm going to do the same thing for that second group, for the green set of terms. Now, if the first term in this group is negative, then I want to make sure my GCF is negative when I factor it out. Now, in this case, it's not negative, so that's not going to happen. And the common factor in 14 and 21 would be 7. So I'm going to put a plus 7 here as my GCF. Make sure you include the sign. In this case, it's a positive. So I'm going to include the plus, but again, if that was a negative 14, I would have factored out a negative 7. I made sure to put the minus. And then 14x divided by 7 is 2x, and 21 divided by 7 is a plus 3. Now, at this point, you may notice that these two sets of parentheses, these two binomials, are the same. If they're not the same, you did something wrong, and you're going to have to go back and redo your work. All right, so I'm going to take one of those sets of parentheses and I'm going to make that one of my factors in this quadratic. So 2x plus 3. I'm not going to take it twice. I know it shows up twice, but we're going to take it just once. And then the other factor in this quadratic, the other binomial, is going to come from the two GCFs. So the first GCF was an x, so that's going to be my first term. And the second GCF was a 7. That's going to be my second term. And then we are done. This is our factored form of 2x squared plus 17x plus 21. Again, you could always FOIL it together or use distributive multiplication to check your answer.